Okay, so let's use the same line approach and say I had an equation now 2y equal to 10. Okay, so what does that mean? Now I know I can substitute different values for y, but what this is saying is when I add two of those y's, whatever that is, say I had these two, when I add these two y's, I'm going to get 6 because here y is 3. Total is going to be 6. So it's again the same thing. I have a starting point and I have an ending point. This was 6, so 7, 8, 9, 10. And I want two y's to fit into this, which means I split this into two. That looks sort of at the center. And so this is y, which is 5, and another 5. So once I have a single variable, this equation is very easy to solve because I just have to split that length into two pieces. So this I think is fairly straightforward to understand, right? So let's say we had some equation in which you had 2y plus x is equal to something, 13, okay? And I had 4y plus, let's say, same x for now, okay? This is equal to something else, so let's say 17, okay? So the question is, what value of x and y will satisfy both? That's the same thing we've been talking about. So 2y is, I have 1y, I have 2 y's, could have used different colors, I have some x, and then this total has to be equal to 13. So actually my question is, the starting point is here. I know this is 10, so that's 11, 12, 13, right? I mean from the top. No? So I have 13, in which I have added 2 y's and I have added 1 x, and we are getting 13. Now this has not got a solution, this has got many solutions. Same way I look at the second one, it was at 13, now I'll be 14, 15, 16, 17. Now I'm saying 4 of those y's plus an x somehow has to add to 17, right? So now this also has many solutions. So the question is, when I do elimination, which means I can see plus x here, I can see plus x here, it's the same length being added in two places. Why can't I just delete those two x's? What will happen if I didn't have an x? Then I will be able to solve it, right? So they say, what do I know about this equation? What do I know about this equation? And if I eliminate the x, then what is left will be an equation in y which I can solve. So that's what we do in elimination. We take the first one, which is 17 length. So I say whatever, 4y. Okay, I'll use two colors this time. And it turns out if I subtract the two, I'm going to get, this is a positive number, so I'm subtracting. So when I do this minus this, I'll be left with 2y. A shortcut to that is, if the number is positive, you make it negative. If here also it's positive, here also it's negative, and then you just add. So, but it's the same thing, you're removing 2y from 4, however you look at it. So 2y is left. This is all the same, so the x's get cancelled. That was the whole point. I don't have to worry about that length. And so what's left here is basically coming as 4. So 17 minus 13 is 4. So this tells me, when I do solution, the problem has been reduced to, if I had two y's like this one, the full length is 4. So the solution of y is just going to be 2. That's it. So what this means is, two y plus x is 13, and 4y plus the same x is equal to 70. So these are all 2's. And now let's check, and when we check our answer, this is what we do. We say, okay, that means x should have been, this was 4 gone, this was 13, 9, right? So what is left is 9. Okay, and this is 8 and 17, this is also 9. So these two are the same.